Alright, math friends, we are here to talk about the distributive property. Last week, we worked on the distributive property when we sliced arrays in half and made them two smaller arrays. So we're going to work on that a little bit more today, but this time we're just going to use numbers. So let me show you a few examples of the distributive property. When we worked on it last week, we did examples like this. We took a problem like 7 times 8. We kept one of our factors, which in this one I kept the 8. But then we split up the other factor. So instead of using the 7, I split it into a 4 and a 3. Okay, when we solve 8 times 4, we sing one of our skip counting songs and we get 32. And when we solve 8 times 3, we sing another skip counting song and we get 24. When we add 32 and 24, we find the answer to this problem. 7 times 8 is 56. Okay, this is an example of the distributive property because we kept the 8, but we split up that 7 into two smaller numbers. Okay, when we draw this array out, we can draw a line to show how we split this. Okay, here's another example. It's the same problem. It's 7 times 8. So what I did for this one is I did the exact same thing. I kept the 8 here. Okay, but then I split the 7 into a 3 plus 4. This is the same thing as I did before. This is just like writing 8 times 3, which is what I had up here, 8 times 3, and 8 times 4. So I distribute the 8 to the 3, and then I distribute the 8 to the 4, and make that an 8 times 4. Again, we get 24, and we get 32, and when I add 24 and 32, I get 56. So this is the same thing. I'm splitting 7 times 8, but I'm doing it a different way. I kept the 8, just like here, and I split up the 7 into a 3 and a 4. Okay, this means the same thing as 3 times 8 and 3 times 4. Okay, here's another way to write it. Same problem. I've got 7 times 8 again. Okay, I had to keep which number? Doesn't really matter, but which number do you see that I kept? You can see that I kept the 8. Okay. What number can you tell that I broke? I broke up the 7. I've got the 3 and the 4 to represent the 7. So let me solve my parentheses. 8 times 3 is 24. 8 times 4 is 32. When I add those together, I get 56 again. Okay. So all three of these examples are all the distributive property. I just wrote it a different way. Okay. The first way is the way that we practice, where I just split it. I kept the 8 and I split up the 7 into a 4 and a 3. This one, again, I kept the 8 and I split up the 7 into a 4 and a 3. And in this problem, I kept the 8 and I split up a 7 into a 4 and a 3. All right, let's do an example over here on this whiteboard. Let me find a new example. Let me do, I'll do 6 times 9, okay? So let's split up a number. I'm going to split up the 9. I'll keep the 6 the same. So I'm going to keep the 6. I'll split up the 9 into 6 times 3 into 6 times 6 because the 3 and the 6 is 6, 7, 8, 9 will get me that 9. Okay? When I solve this, I'll get 6 times 3 is 18 plus 6 times 6 is 36. Okay, I add those together to get my answer. So my answer is 54. Let's do the same problem, but let's write it a different way. Let's do 6 times 9, and let's set up my parentheses. Okay, what number do I want to keep? I choose to keep the 6. So I'm going to put a 6 in each one. Okay, I choose to keep the 6, so I'm going to break up the 9. I'll break up the 9 into a 3 and a 6 because 3 and 6 together get me that 9. I'm going to solve my first parentheses, which is 6 times 3, and that's 18. Solve my next one, 6 times 6, which is 36. When I add those together, I get 56 again. So 6 times 9 is 56. Let me show you the last way that we did it. Okay. This way, I have one set of parentheses. So what number do I keep? I'm going to keep the 6. So I'll put the 6 out here. I'm going to break up my 9 into a 3 and a 6. Okay, because 3 plus 6 is 9. I'll distribute that 6 and make it a 6 times 3. And I'll distribute that 6 again and make a 6 times 6. I get 18 plus 36, and that gets me 50. Well, that gives me 54, doesn't it? Gets me 54. There we go. So you just use the distributive property on the same problem, but it's written 3 different ways. So no matter which way that you write it, know that what you're doing is you're keeping a factor the same, and then you're splitting a factor, okay? By doing that, we make big multiplication problems like 6 times 9 a lot easier to solve. All right, guys, you did a great job.